program, and we want to welcome you guys to the inaugural Fire on the Fives. The concept behind this is that this will act as a webinar series held on or around the 5th of each month, where we bring in experts from within our own agency and our partner agencies to present on the latest in fire science or fire operations, issues of interest to fire weather forecasters and IMETs into offices. So we welcome everybody that has gotten on. Just go through some initial logistics here. Please ensure that if you're putting your phone on mute, that you do put it on mute and not on hold. We will take questions at the end of the presentation unless, and of course, if our panelist, our guest today, Mr. Chuck McHugh, if he wants to take questions during the presentation, he'll let you know. And the other change is that right after we sent out the announcement of where these are being recorded, and we were going to post them to the IMET Google sites, but we have actually come up with a new National Weather Service Fire Weather Google site. You can see the link at the bottom there. We will ensure that that information gets out to the program managers, and from there out to the rest of you. So there is a change there in where these recordings will be housed. With that being the case, I would like to again welcome our guest panelist for today, Chuck McHugh. He's with the U.S. Forest Service. He's a fire spatial analyst. He works at the Missoula Fire Sciences Laboratory that's part of the Rocky Mountain Research Station. And today he will be presenting on Kestrels versus Sling Psychrometers and some study he's been doing on that. So with that, I'm going to change the presenter to Chuck. Chuck, you should have control now.
Okay, thanks, Larry. Can everybody see the title slide there?
Yes, we can.
Okay. Well, I'm here in Missoula at the Fire Lab. I have my colleague here on this work, Larry Bradshaw's in the room too, so be sure to direct all questions to Larry. We're going to just talk about some work we're doing comparing Sling Psychrometers to digital weather meters. With that, I guess we'll just get started. Because we're using stuff that's out there in the marketplace and everything, I have to give this standard disclaimer that any of our work or anything is no endorsement of firms or corporation names, and that we're not endorsing anybody, just for the convenience of the presentation and what we're doing. So right off the bat, why study? So Maynard, in a paper he did in 2011, made this note that he was getting feedback from firefighters that there was a strong lack of confidence in RH data they provide because they're so much higher or so much lower than Sling Psychrometers. Gary White, who did a paper in Fire Management Notes, noted the same thing, that instruments are consistently giving low relative humidity readings compared to those derived from using a Sling Psychrometer. But probably the more disturbing thing are these two comments that Gary White documented in his paper about actually changing the readings because they figured that the Kestrels aren't right, so they're just adding to those values to get what they perceive to be the correct reading, or that they refuse to use them because they push them out of prescription for conditions, or they just don't even use the Kestrels because of how low they are compared to Sling Psychrometers. That got Larry and I thinking about this a little bit. We've been kind of messing around for a little while with this, and then we finally got started on it. But those two comments there bring up this whole idea of truthiness from Stephen Colbert, that said, that you're making an argument or assertion based on your gut feeling or intuitive because it feels right without any regard to evidence, logic, intellectual examination, or facts. So hopefully with what we're doing, we can add some facts or some data to this question and have some discussion about that. We know that field readings from a Sling Psychrometer to a Kestrel would be different. I mean, you just think of the differences in the instruments you're using. This is data comparing temperature in RH, calculated RH from the slings versus the Kestrel across a series of measurements across a day in October on a prescribed fire here on the Lolo. And consistently the Sling Psychrometer, I'm going to just say SP for the rest of this talk. We're 1 to 4 degrees lower, and the RH was anywhere from 3 to 14% higher. And that's just on one afternoon on one fire with one observer. Trevor, in his paper out of San Dimas, did a pretty good job here of kind of showing how those things could differ in instrument accuracy based on the electronic meters up here on the top versus the Sling Psychrometer. And you look at slings and everything that goes with trying to get the calculated RH value, and a lot of it's all user. You know, how well are you reading the thermometers, your techniques, how you're recording the data, if you're estimating the elevation correctly or using the wrong tables, as in the bellwether kit, you grab the wrong one. Interpolating RH values from the tables, you know, not getting the right wet bulb and dry bulb readings correspondingly. So compared to electronic meter, which mostly it's just a result of calibration or instrument drift over time, and there's a little bit of user technique with the digital meters, but certainly not to the extent that we see with using the slings. I mean, there's lots of reasons why the sling could be higher than a Kestrel. You know, the sock and the wet ball's not clean, or it's not wet enough. The water that you're using isn't clean. A lot of it's technique. You're not slinging the psychrometer appropriately or long enough to get the wet bulb temperature to come down. The thermometer readings aren't read quickly enough, so they're rebounding, so you're not getting an accurate reading of the wet bulb. Not reading the thermometer correctly, so those numbers, I know for me, as I get older, even with reading glasses, they get harder to read on that little 4 or 5 inch thermometer. And even us in this study that we're doing, we've come across that just between Larry and I. Calculating incorrectly from the tables, you know, so you're not on the right table, and then elevation differences. And both White and Maynard outline and discuss those things in both their papers. So how they work with this crowd, you know, everybody, you guys all and gals probably all know how this is working with the tried and true belt kit that's been in use and out there since the late 50s, early 60s versus the Kestrels. The little thing with the Kestrels, we're using a 42 4500s and then a Kestrel 3000 here. 2 Kestrel 3000s. This is just a close-up look on the 4500s. This little blue pigtail here is the temperature, and this thumbtack-looking thing is the RH sensor. And then on the 3000, here's the temperature. It's external, but this is the humidity sensor on the 3000. It has a little diffuser screen behind there, and then the RH thing is in there. Both of them calculate temperature and RH, are done independently of each other. There's no barometric pressure involved. There's no elevation involved. It's strictly based on these two independent sensors. So how it works. For RH, what Kestrel does is they use a capacitive humidity sensor, and on the Kestrel, as the humidity increases with the increase in the capacitance. So as this little capacitor here changes, either here or on here, then the humidity increases as that capacitance increases. So it's about how it changes incrementally and nearly directly proportional to the relative humidity of the surrounding environment. So there's no pressure or anything. It works independently. On temperature, what they do is they use the thermistor, and that's the thumbtack or the little squiggly pigtails that are external. And there's two ways, either a positive temperature coefficient or a negative temperature coefficient. The Kestrels use a negative temperature coefficient, so as the resistance that decreases with increasing temperature. So as the temperature goes up, the resistance goes down. And that's how it records temperature. Now, Kestrel, they have a stated accuracy for both their relative humidity and temperatures. For Kestrel, this is right out of their specification sheet. They say that it's plus or minus 3%, as long as you let the unit to be calibrated to the external temperature, you don't expose it to large rapid temperature changes, and you keep it out of direct sunlight. And over time, if you don't do anything, just over time, the capacitance on that sensor is going to drift plus or minus 2% over a 24-month period. So think about people who carry Kestrels and where they're sitting in their radio chest packs, in their pockets of their fire shirts, stored in their line gear, and how those are being treated on the line. For temperature, they state that it has a stated accuracy of less than 1 degree Fahrenheit, but that it also needs to have airflow over that, and that provides greater, faster response and reduction of insulation effect. There's negligible calibration drift, and I would say that's probably true because we just got all 4 Kestrels that we were using back from the company. We sent them in to get tested and calibrated, and none of the temperatures had to be changed. They were all within their acceptable or allowable calibrate stated accuracy levels. So nothing was done to them in terms of temperature. There are some issues with digital weather meters, operational environment. You think about how we're using these on a fire line, and fire line is probably the most pretty offensive environment for digital weather equipment. People are keeping them in their pockets, like I said, carrying them in line packs in their chest pockets of their radios. They need time to equilibrate. Hopefully people just aren't pulling them out of their sweaty line pocket of their fire shirt, opening it up, taking a reading, and using that. They're giving them time to get adjusted to the environment that they're in. They do require some maintenance, keeping the batteries up. And then calibration. Calibration for the RH sensor and calibration for the temperature to make sure that they're not moving around as they get exposed to dirt and salt and stuff. I often think about, what happens if one of those falls out of your chest pack into the porta tank full of foam agent, and what happens there. RH, to get really good RH, as they say, you need to avoid direct sunlight, you need some type of airflow, and if there's no wind, they say that you need to have at least 15 minutes to let that thing come to equilibrium with the environment, operational environment that you're in. So that's a little background on Kestrel instruments and that. Previous studies, there's been three looks at Kestrels compared to slings. So the first one here was done through MTDC and by Greg Lemon and Dick Mangan. They did this about 2000. And they basically took one Sling Psychrometer reading and then compared a bunch of digital weather meters to that one Sling Psychrometer reading and evaluated them all against that one reading. And they used the Sling Psychrometer as their gold standard. They figured that the Sling was it, and that's what they were compared to. Gary White, who is a retired BLM criminal investigator, wrote this article in 2011 in Fire Management Today, talking about Kestrels and Sling Psychrometers, and he doesn't present any of the data. He talks about his methods and what he did and how he went about it. I'll talk about that a little later. And then Trevor from San Dimas did a good job of looking at the digital weather meters, talking about what they are, what they're measuring, what their strengths are, what their weaknesses are, and how they could be used in wildland fire management, but did no real comparisons between data collection methods from the two. So like I said, Lemon and Mangan, they compared a bunch of digital weather meters. Kestrels were one of them. They tested that against a single Sling Psychrometer in an uncontrolled environment, outdoors. They used this one Sling reading of 45 degrees Fahrenheit and 53% RH, so not really fire weather environmental conditions. And what they found was that the Kestrel 3000 that they used at the time was the temperatures were nearly equal and the relative humidity was about 4% lower. Gary White, in his thing, he did a bunch of random field comparisons of a sling readings and calculated RHs to Kestrels. So as he walked around throughout the summer, he would stop and take a reading with his sling, take a reading with his Kestrel, and compare them, and said that the Kestrel was typically 5 to 6% below his Sling Psychrometer. And then what he did is he sent his Kestrel in and asked to a lab and had it certified at 3 set points of RH, and his Kestrel matched up to those certified and tested RH set points, and then based on that, he was making the recommendation that the Kestrel is likely a better instrument to use than the slings. Again, there's no data to present. It's in an uncontrolled environment except for the testing that was done after the fact on his Kestrel. And then again, Maynard, which is a good article, that he specifically talks about Kestrels and recommendations on use. He doesn't, again, compare any of the data or make any evaluations. He does a good job of discussing their features and functions and talking about the error associated with Sling Psychrometers. That's where that one chart I showed early on in the presentation came from. So the approach that Larry and I are taking is we're taking Sling Psychrometers and comparing them to Kestrel readings. We're trying to do it in as a controlled environment as we can. We're using 2 Kestrel 3000s and 2 Kestrel 4500s. And we have 2 Sling Psychrometers. And then we're testing these at a set point temperatures and RHs, different combinations. I'll show you a table here in a minute. But at each set point of RH and temperature, we're doing 3 sling readings. So we'll do one reading with the slings. We'll copy everything. We'll wait 5 to 10 minutes. Then we'll do another reading we'll do a sling weather again, etc. So we're getting 3 samples of the sling readings compared to the Kestrels. And then we also have what doesn't say in here is we also have a digital meter that we're using that we're considering as our truth. And we'll talk about that a little bit later. But here's our data range. We're looking at combinations of 5% at RH at 80 and 100 degrees, 10% RH across 60, 80, and 100 degrees, 30% RH at 60, 80, and 100, 50 RH at across 60 and 80, 100. So 11 different set points with 3 different sling readings at each set point. We're doing 2 phases of data collection. So phase 1, we just took Kestrels and Sling Psychrometers as is. So we borrowed a couple 3000s from a fire module here in Missoula. I grabbed those. We just took them as they gave them to me out of their line pack. Those are the 3000s. The 4500s Larry and I had, and we had them they've been pretty gently cared for because they've been in our desk drawers, so we used those. The Sling Psychrometers we took one out of a belt. We have a belt. Mine came from a bellwether kit, but we had 2 other ones, and we didn't do anything to them other than to make sure that the mercury was not broken up in them, that they were functional slinging, and there was no issues with that. But we didn't change any of the socks on them. We just took them as is. And we didn't use distilled water. We just took regular old tap water because I doubt anybody on a fire line is carrying distilled water. They're probably more than likely using their canteen. Phase 2. So what we did is we sent all 4 Kestrels off to the company and NK and had them test and calibrate all 4 Kestrels for both temperature and humidity following the standard certification calibration that they would use if you sent one into them. We are currently in phase, and then with the Kestrel, with the slings, we put new wicks on the 2 that we're using the sling weather, and we're using distilled water this time around. And we're currently in phase 2. We're just about done with phase 2 of the data collection. We have about 3 or 4 more set points to get. Hopefully we'll be done by next week. We haven't sat down and looked at any of the data yet for that. So basically, what we're going to show you today is some of the information from the phase 1 portion. Our goal is to, once we get the second phase done here, is to do analysis on the results and publish it as an RS research note, and then look at various ways to communicate it to the field, probably another webinar or two, like through Lessons Learned Center. So when we say controlled environment, here we have at the lab this environmental chamber. You can see it's really sciencey. We have all kinds of tubes and knobs and power boxes and all that here, but it's a self-contained unit that's in the lab. Temperature and humidity are independent of each other as much as possible. We can set the temperature that we want. We can set the humidity that we want. This green value is set values, and then the red values here are what the measurements are inside the lab based on in the room, in the chamber, based on the sensors that are in there. So in this case, it's 26C, but it's reading 28C in the chamber, and here 30% RH and 31% in the chamber. Those sensors, though, are located up in the upper, as you're standing in and looking at her, in the upper right-hand corner of the chamber. Here's the main door, here's the temperature sensor, and here's the RH sensor. So we can't really sling weather up adjacent to those. So what we've done is, and the other thing with this is, we're doing the best we can with this chamber that we have. Certainly, it has to work to maintain what we put it at. This is a reading of 24 hours from 5 in the evening to about 4:30 the next evening. These are in 1-minute increments. RH is on this axis here, temperature in Fahrenheit is on this axis. Here's the RH trace across here, and the temperature trace across here. And it's based on 1-minute collection intervals. And you can see the cycling that's going on in here in the chamber as it tries to maintain the RH and the temperature set points that we've set up on the control panel. As you get out here on the end of this, this is some actual data sampling we did, and these red points are collection points on there. So you can see that sometimes we're at the high end of the temperature cycle, sometimes we're at the low end of the temperature cycle, and it's just the fact of life with the chamber that we have. It's probably one, if someone wants to level a criticism at it, is that we're in this cycling throughout all of our sampling, but I'll show you some of the data with one collection interval. Yeah, so here's 1 hour. And you can see within 1 hour, it went from this peak to this middle here and cycled down. So here's the range of data cycling for a sample set point of 100 degrees Fahrenheit at 5% RH. Temperature in Fahrenheit is on this axis and is the red trace. Blue is the RH, and its values are on this trace here. And this is for basically a 30-minute period. So you can see how, over that 30 minutes, how it's changed. The mean RH during that time was 5.8%, and the mean temperature was 94 degrees, almost 95. So we never really did get it to the 100 degrees we wanted, but we were at this point here. These 3 shaded bars on here are 3 separate sling measurements that we did on this cycle. So here's one, here's the second one, and here's the fourth one. So you can see the range of data that we were getting for temperature and RH. Here we're at a 7% RH, and here we're down in the mid-90s. Here we're in the mid-90s for temperature and about between 6 and 7% RH. And here we are at in the mid to high 90s, and then down into 6 to 7% RH. Here's the 2 Kestrels we're using, but we also have a couple other digital instruments. And we're using both of these before we even started phase 1. When I purchased them, we had them set and calibrated to their standard temperature and RH set points. We're using this one here because we can see what it's reporting in terms of temperature and RH. And we're using this one because it's collecting temperature and RH both. It has the ability for us to set marks, and in fact, the data that I showed earlier with the cycling and the red dots is based on the data collected from this. When you compare these two together, they're very, very close to each other, but we decided to use this one because we can mark it, which comes in handy when we're able to mark it when we start our slinging, we're able to mark it when we end our slinging, we're able to mark it when we start reading the other instruments, and it helps give us some time tags with the data. And we're using the LogTag, this blue LogTag here. We're considering our version of the truth, or the values that we're comparing everything to from the slings and the Kestrels. And there's a reason why we're doing this. It's because if you remember, I said that the temperature and humidity sensors for the chamber are all way up in the upper right-hand corner. So what we've done is we've arrayed these, our fancy instrument array here is hanging in the chamber. We're slinging weather about right here. So here's our LogTag. We have this other sling that we just have sitting here to just measure dry bulb off of only. Here's the digital instrument that we're reading that we can see that's pretty close to this one. And then the 2 Kestrel 3000s, 2 Kestrel 4500s. And the other thing that we tried to do in phase 1, but we weren't successful, we had some technical issues, is we have the same RH and temperature sensors used in raw stations, and we have them hanging, one right here and one right here. And we think we've gotten through all the technical issues, and they seem to be working fine this time. So in addition to what we're doing with all these digital and the slings, we're also getting corresponding information from 2 separate raw sensors. So some phase 1 preliminary results. I'm only going to show one slide of temperature. Across all the slings and all the digital thermometers, they're so close on their dry bulb and ambient air temperature that while we'll address it more in the paper for the purposes of this presentation, probably this is the only slide of temperature we're going to show. So this, what is shown is the cluster of around our temperature set points of 60, 80, and 100. This black line would be perfect agreement. Here's the cluster of the sling dry bulb temperatures and the sling for both slings, A and B, with in addition to the LogTag, the blue LogTag that we're considering our truth. And that's the same all the way across. You can see they're pretty tightly clustered. Here, they're all below because we didn't achieve 100 degrees at the level where the instruments are hanging in the chamber. So that's why they're all below the 100-degree line. So with Kestrels, here's the same type of information, but this time it's all the Kestrels, all 4 Kestrels clustered around our digital, the blue LogTag, which is the green diamond. So you can see the cluster is a little tighter, and the spread, I tried to do error bars and scatter, and it's just so tight that it doesn't even really show you anything. Here again, they're all below the perfect agreement because we never achieved 100 degrees in the chamber with any of them. So then on to RH. So this first plot has the measured relative humidities from the Kestrels. Of course, the relative humidities for the 2 slings are calculated based on their Whipple dry bulb. crossed here is the target humidities from, so these are actually, while I'm showing these as traces, they're actually individual data points at 5%, 10%, 30%, 50%. The slings are these dash lines, and Sling B is this blue slash dash line here. Sling A is the orange dash line here. The instrument that we're using as our gold standard or truth is this LogTag, and it's this bright red line, and its trace is basically running right through here. You can see the Kestrels are grouped around it, except for this one Kestrel here, which is one of the 4500s. It's Kestrel. It's this Kestrel B. The interesting thing here, I think, is when you look at the 5 to 10% range, that how high the sling calculated RH values are for both slings, between 5 and 10%, compared to our trace here of what we're considering the truth. You just don't look at the red line. You know, the red line at the 5% was pretty much about 6 or 7%, and look at the spread here, anywhere from about 16 or 17% to as high as 21%. And what we noticed is that, for the most part, there was even differences between the slings here in calculate RH. Now, some of that could be attributed to user error and technique. Larry and I, just not one person using the sling. We're alternating between who's measuring weather with the Sling A and Sling B, swapping off between them. But what you can see is that the lower RHs, the slings are higher. As you get into the wetter RHs, you tend to have a collapsing of the sling data, calculated RHs, to the instrument sort of measured RHs. Again, this one right here is a wacky data point because the user, in this case me, had poor technique on that measurement, and I didn't get the wet bulb wet enough, and the wet bulb temperature never came down and was too high. So so the calculated RH was higher than it should have been. If we just break it out, so we're just looking at the two Sling Psychrometers as their step points compared to the RH, just to look at it. Sling A is the diamond, Sling B is the squares. And now you're seeing it not as the trace like before, but the actual data collection points compared. So you can see Sling B here was 21%, here Sling A was 18, but the measurement from our truth that we were going with was about 8%. Well, it's showing you that they're always higher than what we're considering our truth or gold standard to be in this study. If we look at the digital readings, you see that they're pretty tightly clustered, even without any calibration. The one exception is this Kestrel 4500B that was definitely out of calibration for RH. You can see it made a big difference at the low end of RHs, but at the wetter end of the RHs, not so much. It's pretty, probably if I had error bars and stuff on here, it's probably not too far off the confidence intervals across that trace. So we've got this one's been fixed, and I would say that from my memory of looking at stuff and the stuff we've done, it's now more in line with the other Kestrels in the LogTag. So if we look at, this says measured relative humidity, but should really be calculated relative humidity. Here's the set points, relative humidity that we had. Here's the one-to-one line. In this case, this one-to-one line is not on the target set points we have, but it's actually representing what the measured RH value was on the LogTag. So we're measuring what we got off the calculated RHs from the slings to the LogTag here. And this just is another way to illustrate that the slings at the low end RHs were way higher, much higher than they were compared to what we were getting the digital instrument. As you get higher in RH, they get still higher but closer to it, and here you see quite a spread. And some of that's driven by the Sling B typically always being higher than Sling A, and then this is the one real errant, couple errant data points here from technique issues. So we just looked at the RH differences, and I was doing this just to focus on this 4500B. Here's the LogTag RH that we were getting. So you can see here's what our target RH set point was, but here's what we were actually getting at the height in the chamber that the instruments are hanging in. So if you take the RH derived from that one Kestrel, it was anywhere, from 5 to almost 7% higher at the low end RHs than what we feel we were actually getting in the chamber at that point in time for that instrument. And that's just taking that same chart data and plotting it. Here's the zero line. If they were perfectly agreed, here's that Kestrel 4500 again over all the data that we had with it. You can see again it's lower here, and in fact, two of these Kestrels were this is a 3000 and this is a 4500. Here we're below that. They were actually lower probably by 1 or 2%. So thoughts so far, even in the controlled environment, we say controlled environment, I should probably have that in quotes, because you can tell that we can't keep it at a steady state for the whole sampling period. The machinery and stuff has to cycle through to try to keep it to the target set points we're getting. So there's differences between the same type of instruments. You see that both digitally, the digital ones, and as well as in the slings. The Sling Psychrometer calculated RHs were always higher than the Truth, and at the lower RH values, the slings were always much higher than the RH ranges that we got with the digital instruments. Right now, what we were seeing was more agreement amongst the digital instruments than the slings. They're more closely aligned with each other. What's next? Like I said, we're already in this. We sent the Kestrels off, got them tested and calibrated and certified. We have the two slings that we have been using. We've put new wicks on them, and now we're using distilled water. We're almost done with repeating the measurements for the second round here, and then we can do the analysis and then work on getting the research note published. So hopefully, I'm hoping by I'm going to say early July, maybe we'll have something to hang our hats on that we can talk about a little bit more. I have to thank Kyle Wald. He's an engineer here who's helped us. He's the Doctor Who of the environmental chamber. Paul Sopko here at the lab who collected the CY data for us, and then Mark Finney here at the lab has provided some of the funding support for the work that we've been doing. And with that, I guess I don't have anything to say. Larry, is there anything you want to add?
No, not really, other than that last graph that Chuck showed, that one there where the black line was a Kestrel 4500 and the green line was the Kestrel 4500. They were furthest from the Truth. And when they went back to recalibration, the 3000s did not need to be recalibrated. The 4500s did, which was sort of interesting since the 4500s didn't have the line exposure and things like that, and they were newer instruments too. So it was kind of interesting that the 3000s were more just better calibrated with more use. And we think it maybe is the placement of the sensor. If you remember that picture on the 3000, it's kind of embedded in the back, and the 3000 has a sheath that it sort of lives in, the plastic sheath, and the 4500 is more exposed. So anyway, that was a little surprise to us.
Yeah, because these Kestrel 3000s, sure the older ones too. So just even on drift, they should have been out of alignment. And I talked to the person I got these from, and he said they hadn't been calibrated for 5 years. They were just what he carries around in their line packs for checks and stuff. So they have a hard plastic case that they reside in too.
Is there this is Robin, I have a quick question. Is there a common practice with how often these Kestrels are sent back in, or should be sent back in for operation?
If you visit the Kestrel site for fire stuff, they suggest that they should be done yearly, or if they're exposed to extreme environments, like they get kind of heat impinged. I think that if they, the calibration, these things, when they calibrate them, are all done with salt. They're calibrated to salt. So when I jokingly said about it falling into a porta-tank full of foam agent, or it's in your pocket and you get hit by a load of retardant drift or something, there's a lot of, I would say that you probably need to think about how badly they've been impacted and whether you need to have them calibrated. They have a home calibration kit that you can buy that's much cheaper than sending it into the company to do. These cost $75 a piece for temperature and $145 a piece for the relative humidity. And I think, once you make the initial investment in the calibration kit, the replacement salts that are required to do it are much cheaper than that.
Chuck and Larry, thank you very much for the presentation. I'll turn it over to the field offices, see if there's any questions out there. And I'd like to start out with one question to you guys, to Chuck and Larry, is obviously some of the ramifications of this may be in light of your quotes that you had at the beginning of the presentation, is I think maybe some folks' mental model of what's going on in the fire environment in terms of fire behavior versus what they think is the relative humidity going on at some area. You mentioned some folks just add 5 or 6 to whatever reading they're getting on the Kestrel to kind of make it in line with their mental model. What do you see the ramifications of this study in terms of folks' perception of what's going on in the fire environment?
That's a good question. I mean, it's everything, right? Think about fire investigations and fire reviews on escapes or entrapments too, what that means. And I think, with any type of temperature or relative humidity reading, right, it's not the single point in time, it's the trend that's important. But you're right, if your targeted expertise is at 1 RH and temperature's not that big a deal, I don't think there's that much difference. It's the RH that's the kicker. You're going to have to reframe that, I think, and think about that.
The other thing that we're seeing, we didn't get it in the first time with the RAWs, the Sala sensors, because we didn't realize how fast things were going to be changing in the temperature, humidity in the environmental chamber. So we had it set at taking it in readings every 10 minutes. And so now we're taking them every minute, matching everything else that's electronic. Initially, we're seeing them, the Sala RAWs sensors being right in line with the truthiness of the LogTag. And these came from the shop there in Boise, and they've been calibrated in December. So I think having the electronic instruments and the RAWs sensors in agreement is going to be a pretty big highlight to check the validity of what we've been looking at with the slings over the years.
Hey, this is Joel and Juneau.
Go ahead, Joel.
Yeah, hey, tell us a little bit about the LogTag. I mean, how is it slewed to? Why is that the truth?
Because it's brand new and it was NIST certified from the shop.
Okay, and so what you'd like to think is that LogTag is going to say almost exactly what your calibration of your chamber is, right?
Well, it's telling you what the actual chamber is at that moment. Again, we've been having a hard time getting the set point and to reach the set point sometimes with the cycling. So we think the LogTag is the most accurate reading. That's what's really happening where the instruments are lined up.
Yeah, because remember this, the temperature and humidity sensors for that control panel are mounted up here, and we're measuring it here, which
Cool.
that's why will be different. There is air circulating in this chamber. When you're standing there, you can actually see these instruments will swing a little bit, so we do have air movement in there. So we realize that there's even changes in the location of that chamber. These are pretty close as we can get them spread-wise. We've tried to get them all at the same height, but there will be a difference here compared to up where the sensors are in the chamber itself.
Well, I sure like my Kestrel.
Well, it'll be interesting to see what comes of this. We ended up in wildfire today, so Bill Gabbard has gotten a hold of it.
Any other questions from the field?
Thank you so much. That was really valuable.
Yep, you're welcome. Thank you for the opportunity to talk to you guys.
Thank you, and I'm sure when you get done with Phase 2, we'll invite you back to find out what happened.
Yeah, okay.
Sounds good. Thanks, guys. I would like to thank you all for coming to the inaugural Fire on the Fives. Our next Fire on the Fives is slated for July 5th, where we're going to be talking about the new SPOT fire program. The SPOT program is being updated to take into account some updates for fire as well as all other all hazards. So Robin Heffernan will be presenting on the updates on that system, and again, that'll be actually the 5th falls on a Sunday, so it'll be July 6th, and we will get out information to you on that. Again, thank you, and have a great day.
Thank you.